Hello everyone, hopefully you're doing well. In this video, we're going to continue with chapter 6, rational expressions. If you miss for any reasons, section 6.1, rational expression, the introduction to rational expressions, multiplying and dividing rational expressions. I strongly advise you to go back and watch a previous video on this chapter. Now we're going to take a look on how to add and subtract rational expressions. The objectives is really adding or subtract rational expressions with a common denominator. We're going to identify as well, the LCD that we call the least common denominator of rational expressions. We're going to add or subtract rational expressions with unlike denominators. One thing you need to remember about rational expressions, uh, you know, they are like rational numbers and can be added or subtracted. We add or subtract rational expressions in the same way that we add or subtract rational numbers. For example, let's suppose we have uh, 2 over 3 plus 5 over 3. If the denominators are the same, you keep the denominator as is and you add the numerators. So that gives you 7 over 3. So that's when the denominators are the same. But if I have 2 over, I'm going to call this one A and B. If I have 2 over 3 plus 1 over 4, now we said we need to find the least common multiple. What number can divide 3 and 4 at the same times? We know 6 divide 3 but doesn't divide 4. 8 divide 4 doesn't divide 3. 9 divide 3 doesn't divide 4. 10 divide none of them. 11 no. So 12 is the one that can divide 3 and 4 because 12 divided by 3 is 4. 12 divided by 4 is 3. So by what I should multiply 3 to obtain 12? Yes, I can multiply 3 by 4 to obtain 12. So whatever you do with the bottom, you do it with the top. By what I can multiply 4 to obtain 12 is 3, but whatever you do with the bottom, you also do it with the top. So you end up having 2 times 4 is 8 over 12 and 1 times 3 is 3 over 12. Now, you see, same denominator, you add the numerators and keep the denominators as is. So that gives you 11 over 12. That would be when you add fractions containing real numbers. But we're going to do the same with rational expressions. When the denominators are the same, we're going to add the numerators. You see P over Q plus R over Q. Do P plus R over Q. We do the same for subtraction. To add or subtract rational expressions with common denominators, we add or subtract the numerators and write the sum or difference over the denominator. Do not change the denominator, but we're going to change it only when the denominators are not the same. For example, here we focus and see that both denominators are 2p plus 7, 2p plus 7. In this case, we're going to keep our 2p plus 7 in the denominator and add the numerators. So we're gonna add them and combine like terms. We see 4p plus 3p give you 7p. Negative 3 plus 8 give you 5. So there is nothing here you can factor. I would to cancel common factors. We would conclude that the final answer is 7p plus 5 over 2p plus 7. Another examples we can see when we subtract, we see again denominators the same. We're going to keep the denominator as is. Let's keep y minus 2 as is, and we do 8y minus 16. Now, best we can do in this one, we realize there is a common factor on the top. What is the common factor, if you can see? Yes, 8. We can factor 8. So if you factor 8, what do you have left? Y minus 2 over y minus 2. If you want, you can even factor 1, but we've rarely put 1. Now, you'll see on the top y minus 2, at the bottom y minus 2 in a factored form. So what we can do, we need to set the conditions that if y minus 2 is not equal to 0, then you can cancel this 2. You have 8 over 1 left. This is the answer. So the final answer would be a real numbers. We can do something that is a little bit more complicated. So like here, uh, even though the bottom part has 3 terms, you need to compare them one by one. X squared, 3y, negative 10, negative 10. So we are really certain here the denominator is really y squared plus 3y minus 10. And on the top, we have 3y minus 6. Because it's a trinomial in the denominator, we can use the techniques we know how to factor trinomials. If it doesn't work, it doesn't work, but at least try to factor the denominator. Two numbers when you multiply give you negative 10. When you add, give you positive 5. Multiply two numbers to give you negative 10. When you add, it gives you 2 or positive 3. Thank you. It's x plus 5 times x minus 2. Now, when we look at the denominator, we could rewrite 3y minus 6, but except what we learned in the previous video, we said you must always factor out the GCF, the greatest common factor, and cancel out the GCF if you have it in the numerator and denominator. I realize that we have 3 as a common factor. If I factor 3, I have y minus 2 left. Now, when y minus 2 is not equal to 0, we can cancel these two. What we have left is 3 over y. Those are y, sorry, I put x. Those are y plus 5 left. Okay, y plus 5 left. Now, we do something very simple here where all 3 examples we just complete, the denominators are the same. When denominators are the same, the only thing we do, we keep the denominator as is and we add or subtract the numerators, simplify and cancel out again. But remember for B here where I told you for the fraction, adding fractions of real numbers, we need to make sure to find the LCD, the least common multiples. What number can divide both? That's exactly what we're gonna do here. Identify the least common denominator of rational expression. So that's the duty we have to do that. So to add or to subtract rational expressions with unlike denominators, first, write the rational expression as an equivalent irrational expressions with a common denominator. So the least common denominator, the LCD, is usually the easiest common denominator to work with. So the LCD of a list of rational expressions is a polynomial of least degrees whose factors include the denominators in the list. So that's what we're gonna do. This involves finding the least common denominator of two original expressions. Techniques to do it, how to find the LCD, factor each denominator completely. The LCD is the product of all the unique factors, each raised to a power equal to the greatest number of times that the denominator appears in any factor denominator. So I know that sounds a lot of wordings and everything. Let's simplify it into any examples. When I look at this one, the first step, as I said, we need to factor out. I look at the bottom part here, the denominator, I can factor this one out as 2 times 3 times y. How would you factor 4y plus 12? First of all, you see you can factor 4, but you have y plus 3 left, right? Now, we realize the least common denominator here would be the one with the highest degree. It's like for me, this one is 2 times 2 times y plus 3. First of all, the least common denominator or the LCD, the least common denominator, I could take 2 from 6y, but because 2 is repeated twice from the term 4y plus 2, I'm gonna take the 2. Okay, that means I cancel this out. So this one is gone. Second of all, I look at 3 in 6y. I don't have 3 in the second term, so I'm gonna add it also. I need to take 3. Okay. So I take this one. Now, why we don't have it in both? Because we need to take the one with the highest degree. So because if we only have y, we take it, and we have y plus 3. So it's like we take everything. So that would give you 12y times y plus 3 would be the least common denominator, the LCD. Okay. Or the least common multiples, the least common denominator. It doesn't matter how you say that, but that's what happened when you want to do it. Now, anytime you have something that is more complicated, it's like having trinomials. First thing is to factor. If you have x squared plus 4x plus 3, please find two numbers. When you multiply, give you positive 3. When you add, give you 4 is x plus 3, x plus 1. 1 times 3 is 3. 3 plus 1 is 4. If you do x squared plus 10x plus 21, when we factor two numbers, when we factor, give you positive 21. When you add, give you 10. What would be these two numbers? Yes, 7 and 3. 7 times 3 is, um, you know, 7 times 3 is 21. 7 plus 3 is 10. Now, let's go with the LCD. The LCD means we take all the factors, common factors, and factors that are not with. Because we have x plus 3 here, x plus 3 here, we're going to take only one x plus 3. So we're going to have x plus 3. If one of them was power 2, we are going to take the one with power 2. X plus 1 repeat once, I take it, and x plus 7 repeat once, I also take it. So that would be your least common denominators. Do you get it? No? All right, we're gonna do another one then. Here we said that the LCD, first of all, when I see 5x squared minus 5, the first step is really to factor the GCF. But our problem, you need to remember a squared minus b squared is a plus b times a minus b. When I check and see I have x squared minus 1, for me is like x squared minus 1 squared. That I know would be x plus 1 times x minus 1. So in this case, I can continue with that one to say it's x plus 1 times x minus 1. Remember, we must factor completely. It's like rewriting your expressions with only prime factors, so prime factorization. Now, with the second denominator, remember we focus only on the denominators here. When you have um, x squared minus 2x plus 1, two numbers, when you multiply, give you positive 1. When you add, give you negative 2. Yes, it's negative 1 and negative 1. All right. Now, LCD, let's try to see if you remember how to find your LCD here. Yes, 5. I'll take 5. Yes, I take x plus 1, of course. Now, because I see in 5x squared minus 5, there is a x minus 1, but in the second one, I have x minus 1 twice. I'm going to go with the x minus 1 twice. I don't need to put it 3 times. I only need to use the one that is repeated the most. So I can either leave it like this, or I can say it's 5x plus 1, because x minus 1 repeat twice. I can say x minus 1 power 2. So either one is correct. Our goal is really to practice all different ways you can deal with the LCD. When I look at the first one, x minus 3 here, there is no other way I can write x minus 3, because this is a prime expressions, right? But you know what? Uh, if I take the second one, 3 minus x, I said the same way I can rewrite x plus 3, if you agree. Now I can factor negative and have it only x plus 3, x minus 3, sorry. All right, we're gonna do x minus 3. Now, as you can see here, both of the denominators are already factored. Since each is the opposite of the other, you can only use x minus 3, all right, as the LCD here. So we know the LCD. Don't pay attention to the negative. It's only x minus 3 now, okay? Because we can just rewrite it the other way around. All right. You understand the LCD, the least, how to identify the least common denominator of rational expressions. Now, how about adding or subtracting rational expressions with unlike terms? To add or subtract rational expressions with unlike denominators, that means the denominators are not the same. We write each rational expression as an equivalent rational expression so that the denominators are alike. Okay, so first of all, we do our best to identify the LCD of the rational expressions. We write each rational expressions as an equivalent rational expressions whose denominator is the LCD found on step one. Add or subtract numerators and write the results over the denominator and simplify resulting rational expressions if possible. Now, look at that. First of all, I need to identify what is the factors here. We have only 7a. 6a is only 6a. So if you're looking for the LCD, the first thing is take 7 times a times 6. I don't need to take a again because both a's are power 1. So we know the LCD must be 42a. So how can I make 7a be 42a? Yes, I need to multiply by 6. But whatever I do with the bottom, I also do it with the top. To make 6a be 42a, I multiply with 7. Okay? Now we end up, all right? That's very important to see it. 6 times 5 is 30. 6 times 1 is 6 plus 3 is 90. So we're going to have 90 over 42a plus 8 times 7 is 56 over 42a. Looking at this one, you are certain to see that the denominator is the same. We have 42a, and on the top we have 90 plus 56. When you add these two, all right, 90 plus 50, 42, 56 give you 146 over 42a, and I believe you can simplify this one because both of them end with 2. So 146 divided by 2 give you 73 over 21a. And that would be our answer. No, I don't need it from here. It should be right there. All right, that's a That's a very good example, right? But we can do better than that, right? We can definitely do better than that. Look at this one. Um, First of all, as I said, you can rewrite if you want. The first 2x minus 6 give you 2 factor x minus 6. The second one, 6 minus 2x, you can rewrite it negative 2x plus 6. You can factor negative 2, so you have x minus 3 left. Now, what would be the LCD? Okay, you see the LCD is only 2x minus 3. So meaning there is nothing to change. The only thing that would change is 5 over 2x minus 6. Now remember, we said with that one, that's a 5, minus 3 over negative 2x minus 3. Look at the second term. We still have 5 over 2x minus 3, but the second one, 2 negative become positive, 3, 2x minus 3. Same denominator. What we do, we can add the numerators. We have 5 plus 3 over 2x minus 3 on the same denominator. That gives you 8 over 2x minus 3. Do you agree? There is a common factor between 8 and 2 at the bottom because 4 times 2 gives you 8. So we can simplify. We have 4 over x minus 3 final answer. We cancel out the 2 because 4 times 8 is 2 and this one is gone, right? All right. 2 more examples to go. Yeah. Now, first of all, let's factor out. We really need to factor out what is 4x, the 2 factors down here. That's the first thing to do. Okay. I'm going to write, okay, what is for the first term here. So I realize x squared minus x minus 6. How would you factor? Two numbers when you multiply give you negative 6. When you add, give you negative 1 is negative 3 times 2, right? So we can factor this one x negative 3 x plus 2 plus x over what? How would you factor that one? We said two numbers when you multiply give you 6, when you add give you 5. Oh, 3 and 2, right? Now, what would be the least common denominator? Look at the denominators. We have x minus 1 once, x minus 2, we have it both ways, we keep it, and x plus 3. So this is what happened. I need to multiply the first one with what? To have these 3 terms. What you already see? Yes, you already see x minus 3. You already see x minus 3, x plus 2. We have one more term to add is x plus 3. So we need to do it for both of them. The same for the bottom part. We don't see x minus 3, so we need to multiply it for both of them. Now, we can continue. We have 4x plus 3 over x minus 3 times x plus 2 times x plus 3. We have plus x times x minus 3 over same denominator, x minus 3 times x plus 2 times x plus 3. Okay, now the denominator are the same. We can add the numerators. That means we have 4x plus 3 plus x times x minus 3 over everything. X minus 3 times x plus 2 times x plus 3. Let's make more space for that. We can distribute. How about distributions? We distribute 4 times x is 4x. 4 times 3 is 12. Plus x times x is x squared minus x times negative 3 is negative 3x. I'm going to put d for now, so it's over the denominator. Let's simplify. We have x squared plus x plus 12. If we don't make any mistakes, that's what we're going to have over x minus 3 times x plus 2 times x plus 3. Can we factor the top part? There is no two numbers when you multiply give you positive 12, when you add give you only 1. So we said the numerator cannot be factored. So we're going to keep this one as our final answer. Don't forget, you can use those to solve so many other problems. Okay, that's giantly very important. Now that you see this, I can either leave you this one to enjoy, or you can say, you know what? I realize that the first one is only x minus 1. The second one is x minus 1, x plus 1 times x minus 1. And the last one, x plus 1, cannot be factored. It's x plus 1. Now, looking at this one, we can say the LCD is you take x minus 1 because we don't need to take it again with the second one because it's already there. So we take only x plus 1 and we don't need to take the last one. So all we have to do is make sure, because this term right here is 7 over x minus 1 plus 10x over x plus 1 times x minus 1. Remember, we said x squared minus 1 is the same thing saying x squared minus 1 squared. Equals x plus 1 times x minus 1. Okay? Properties. Minus 5 over x plus 1. All you need to do make these denominators be the same. How to make the denominators be the same? Simple. This one has x minus 1. I can multiply it with x plus 1, but whatever you do with the bottom, you must do it with the top. Nothing with the second rational expressions because it already have x plus 1, x minus 1. And the third one, we can multiply with x minus 1. In this case, we make the denominators the same. All right? Very impressive the way we can do that. Now, I need space. Now that we do that, how about we put everything together because the denominator is the same. We can do 7 times x plus 1 plus 10x minus 5 times x minus 1 over x plus 1 times x minus 1. Distribute the top part, 7x plus 7. By now, I'm hoping everyone can do that. Plus 10x minus 5x plus 5 over the denominator. Simplify the top, 7x plus 10x, 17x minus 5. 7x plus 10x give you 70x minus 5x. Would that give you 12x? 7 plus 5 give you 12. Look at that, x plus 1 times x minus 1. Do you agree you can factor 12 on the numerator? 12x plus 1 would definitely be x plus 1 times x minus 1. Cancel these two. We have 12 over x minus 1 as a final answer. Happy? Yeah, yeah, we did it. All right. So hopefully you're having fun with all of this. In a different video, we would return to simplify complex fractions. Take care and have a good day.